Hi all, welcome to my YouTube channel. So in this class, we are going to continue our understanding over the semiconductor devices. So under the extrinsic semiconductor, we have two types, N-type and P-type. So last class we detailed discuss about the N-type and the presence of a donor energy level which will be near to the conduction band. So that is what we detailed discussed. Why the presence of donor energy level that is near to conduction band, everything we have seen detailed. If you guys missed those lecture, please feel free to watch that video and then come back here for understand the p-type. So in order to make the intrinsic semiconductor to an extrinsic semiconductor of p-type, we need to dope with the trivalent atom. So trivalent atom is our interest. The example for these trivalent atoms is majorly we'll use boron. In some case we also use aluminium. So let's take a crystal lattice structure of silicon. Here we can use the boron as the doping atom. So for let's take some simple atom of interest. So boron has only 3 elements in the outermost shell. So that will form a covalent bond with the neighboring silicon atoms. Here there is one hole. So here there is no electron, free electron is there. So it will form a bond, but there is a vacancy of an electron, so that it is called as a holes. So this presence of holes will contribute the presence of free hole. That means free hole concentration will be more in the p-type. So if we take the conduction band, so this is a conduction band and here it's a valence band. So what will happen is that the valence band, this is the acceptor atom, because it has a holes, right? So it's need to accept an electron. So here presence of holes will be here. Holes or electrons will be here. So the layer above or near to the valence band, which will be called as the acceptor atom, acceptor energy level, EA. So this is called as the acceptor energy level. So this is EC or conduction band, this is EV. So this is the numerological we will follow. So as usual, same, the presence of an extra layer of energy level near to valence band, it will make sure that it is more number of free holes are available for here. So last class we discussed, right, the electrons will be available at the above level for the conduction band to conduct more number of free carriers, free electrons. So similar to that, more number of holes will be present in this level, energy level, so that the free electrons or free holes concentration will be higher here. So the concept here is that when a trivalent atom is replaced with silicon, so when a trivalent atom is replaced into a silicon lattice structure, then what will happen? There is only 3 electrons in the outermost shell, only 3 electrons in valence band. So which will form a free holes concentration, increased free holes concentration. So this is what the concept behind that. So it will result in a p-type material with more free holes, more free holes concentration. Okay, I hope you guys able to understand this one. So how the thing is happening. So similar to the N-type, here also the minority charge carrier are electrons. So the majority charge carrier is holes. So P will be greater than N. So the representation how we will do for this thing is that, so whenever we are diagramming and we are drawing in semiconductor, means if we drawing an p-type semiconductor, then what we will do is that, or how we will draw that thing is that, we will give the negative which is inside and then whole presence outside. So this is how the representation that we use for p-type. So why the negative is that it's going to accept an electron. So whenever the element accepts an electron, it will gain a negative charge. So that's what they're mentioning. And the free holes is mentioned here. So similar to that, whenever we are going to get an n type. So n type material will be represented by plus and then an electron outside and dot. Why this is that it going to lose this electron. So whenever an atom loses the electron, we will represent it by the plus. So that's what the general difference. So here the n is greater than that. So how there is an electron movement happen in p type is that there will be an applied electric field. It's considered an electric field in this direction. So this is what the electric field, because of the voltage or anything we applied, there will be electric field. Then what will happen, there will be the movement of holes and other things. So though it is an p type, there will be small minority charge carrier of the electrons also. So the electrons will move in the opposite direction to that, and the current will be produced in opposite direction to that of this. So let me give an arrow mark for you guys to understand. So this is what, this is IN, and this is the electron movement. So this is IN. Okay. So similar to that of holes will move some direction. So holes will move aligned in the direction of electric field. So that will be here. So the same electric field will be produced in the same direction aligned to that. So this is a holes movement. This is the IP. So this is holes. So there will be I net current. I net will be IN plus IP. So this is how the current production because of the movements of minority and charge carriers in p type. I hope you guys able to understand both the p type and n type. So this is how the general things will happen. One more thing is that in case of an intrinsic, both will be equal, that you guys already know. So in case of an intrinsic, the n and p will be equal. In case of an p type, it will be based on the charge carrier. So here what will happen, n will be greater than p. For p type, we know that it will be p is greater than n. So these are the three kind of things we have. We also note that at very high temperature, even the extrinsic semiconductor act as an intrinsic, because the band to band transition or the electron hole pair generation overcomes the impurity ionization, and therefore what will happen, the temperature will be useless. So all the electronic devices will get terminated. So nothing will work at very high temperature. So even at a very high temperature, what the thing will happen is that even the extrinsic semiconductor will behave as an intrinsic semiconductor. So in the next class what we will do is that we will go into a diagrammatic representation of how the both the N and P type are coming into interaction, that we call as the PN junction diode. So we are going to start with the PN junction diode from the next class. Not like that, but how the when we combine both the N type and P type, how the behavior and those things, how the depletion region, what are the capacitance effect at different frequencies, how it will react. So those things we will be seeing detail from next class. So like, share and subscribe the channel. Stay tuned for the next lectures.